Okay, so this is Will, and now we're going to try to do our first real world type of program. And this is taken right out of the exercise manual. And this kind of shows like a real world thing. And this is just a garage door going up and down. And we've got a push button that goes open, push button that says closed. And we have motors that go up and motors that go down. And one is up, one's down, but we also have these limit switches, so it'll go up, 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 up until it gets to the limit, and then we got to turn the motor off. And same when it goes down. So we've got a little bit of a problem here because this shows us 4 inputs. We've only got 3 inputs, and we're using, we have the input. The X1 is our stop push button. X2 is open, and we can use that. So we can use X2, our green push button, to make us go up. We can use our reset, which is X3, to make us go down. Now we can still, what we're still going to do is we have Y1 is the red lamp and Y2 is the yellow lamp. So what we're going to do is, because this close is red, we're going to make Y1 when we're going down. We're going to make Y2 yellow when we're going up. And we're still going to have the green lamp to signify when we're starting our process. Now here we've got a little problem with this limit switches, but what we can use is we can use our C bits, and we can make the open limit C3 and the closed limit C4, and that will probably work for us. So let's go back to our program, and what we're going to do, well, we're going to go offline first because we're going to make pretty significant changes. Our red lamp is going to change, so we're going to delete this row altogether. Now we're still going to have it so when start process it lights the green lamp. And now what we're going to do is we're going to say we need some more rows, or more rungs. So we're going to insert rung, and we're going to need at least 2 of these for sure. One to go up and one to go down. Now again, we're going to use seal and circuits to do this. So how are we going to do this? Well, for sure, we only want to be able to go either up or down if we're starting our process. And then for going up, we said we're only going to do that when we hit the start push button. So it's going to be X002. And that we want to light the yellow lamp. So our output is going to be Y002. Okay, so now we've got, when we're in start process and we hit the start push button, which actually, as soon as we hit the start push button, it's going to be in start process, and we can't, our finger is going to be too slow, so as soon as we hit the start push button, it's immediately going to start going up, and just, that's a limitation of the number of push buttons. There's no way around that. So it'll just start going up. But we want to have that latched in, and we're going to use a seal and circuit as we did up here. So again, underneath this guy, we're going to say we want in this one, we want to insert the row after the cursor. And again, what we're going to do is we're going to put in our normal sealing contact, which means we are going to seal in this output. So this is going to be Y002. Now, what is going to, interrupt this? And this is more the type of seal and circuit that you always see. Now we said that we're going to make this C3, and C3 we said we were going to make that C3. We're going to make that the open limit. So when we hit the open limit, what happens is we want to break this latch circuit. Before we had the start push button. The start push button, again, as we said before, is kind of odd because it is normally activated, so we can use a normally open contact, and you usually show it in line here. But your normal everyday seal and circuit looks like this. So you've got 2 branches. The first branch is the thing that turns this on. The second branch has your seal in, but This one right here is the interrupter. This is the thing that interrupts it. Now it's normally not active until the door gets up there. So again, remember, normally closed contacts, if they're not active, it's going to conduct through that contact. So it will conduct, when we press the push button, it latches this high and it seals it in through this path on the bottom. And it'll seal it in there until we hit that open limit, at which point that open limit becomes active, which means for a normally closed contact, it will not conduct, and that breaks the circuit. And that is how we have our normal seal-in setup. The top row is the thing that turns it on. The bottom row seals it in, but it also interrupts it with this signal. And we're going to do the same thing on the bottom here. So we're going to have our normally open, and this will be the C2. And now we're going to use the reset push button to make us go down. So this is going to be normally open again, and this is going to be X003, which again, the reset button is hardwired to that input. And we said we're going to wire that to the red lamp, which again is Y001. And all our X's and Y's are hardwired, and you can see that if you go into the wiring diagram. That'll show you exactly how it's wired. We're going to insert a row so we can put in our seal-in circuits. This first one is going to be the seal-in, which is the output. It's Y001. The interrupter for the circuit is going to be a normally closed contact. And we said we're going to make that C4. And we're going to put our line to connect it. And when we say we have to manually, every time we put in branch circuits, we have to manually put that line in. So we want to put the focus on that bit, and we want to go to Edit, Line, and now sometimes you have to move it around to get it to the right place, but we want to go up and we want to connect up to there. You can hit Escape to get out of the line mode. And now we just have to go in here and do our address picker, and C4 is going to be the close limit. Okay, so we hit OK, and this should be our program. So we've got the one, that yellow lamp to go up, and again that'll start immediately as soon as we hit the green start button. And then this one will make us go down when we hit the reset push button. Now we have to, get all the way up before we start going down. So we'll have to manually go in here, but this has a nice thing in the project or the program view or tree that we can use this override view, so we can override these values even though we have no external way of controlling them. So let's connect up and see what we got. So we're good to go. We are not going to read what we have. We pretty much never want to. And now we're going to write it into the PLC. And once we start up and we go back into the run mode, like right now our yellow lamp's going to go out. When we first turn it on to the run mode, nothing is going to be on at all. None of our lamps. Before we had the red lamp when we were not in startup, but we want to keep it off because the red lamp now says we are going down. So when we hit start, the start process will be active. When that's active, because I'm still going to have my finger on the push button, the yellow lamp is going to turn on, which means we are going up. So we'll have the green and yellow on as soon as I hit the start push button. And that's what we've got. And it's going to stay that way, and you can see it turned on through this top rung. Now by virtue of this branch right below it, it's staying on because this signal is not active. And while the door is going up, and apparently it's going up really slow, but when it gets to here it's going to go active, and when it goes active, that is going to turn off this branch. That's going to interrupt this circuit right at this C3 point. Now how do we do this? We have this thing called override view, and we can go into here and we have these C3 and C4. And, well, first let's take a look at these values. Well, let me get out of here for a second. Let's first go into our data view. And if we go in here, our C3 and C4 are both off. Okay, these are our open limits and closed limits. These aren't both off. And because they're both going through normal closed contacts, each of these contacts is conducting. So they're both off. So now what we have to do is we'll go into this override view. And here, and because I deleted it, we're going to have to put these back in here. But I'll pull it down, and I want C3, which is the open limit. And I'm also going to put in C4, which is my closed limit. And right now what I'm doing is I'm going up, up, up. What I have to do, because it's off, I'm going to change this to on. And what I have to do here is I have to write new values. So the only one I've changed is this one to go on. So as soon as I hit write all new values, what's going to happen is this is going to go from a conducting state to a non-conducting state, because this is going from off to on, and this is going to drop out. So as soon as we hit that open limit, it stops going up. So I'm going to write all values. Yeah, that just means they don't all happen at exactly the same time, but that's okay. And you can see that opened up and that stopped going up. So now what we have is we have our door all the way up here, and now we want to go down. So when we're going down, first what happens is we hit the reset and it starts going down. As it starts going down, it gets off this open limit. So I'm going to turn that one back off, and then it'll keep going back down, down, down. And then when it gets down, I'm going to turn on this closed limit value. And this is kind of just manually going through how it would be done in real life. So I can still leave this screen on here. I'm fairly sure of that. And as soon as I hit the reset push button, the red lamp's going to go on. So then we'll have our green and red lamp on, and it's going down, down, down. And then I'm going to turn this one back off. Right now it's on. And then I'll turn it off, which means the door is going down and it has gone off the open limit. So now our red lamp's on, so it's going down. So now I'm going to turn that back off, and then this will be conducting again as soon as I write it in. And don't worry about that too much. And you can see now it's conducting, and now as the door is going down, 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 now I need to turn this one on, make this, the actual signal active, which will turn off this normally closed contact. So I'm going to make that on active, and I'm going to write that value into the PLC. As soon as I say yes, this red lamp's going to go off. This will turn into a non-conductive state. Okay? So that's kind of how we wanted to demonstrate the door going on and off. Now, I think we might put an exercise for you guys to do later in there. This just goes on and off at one time, but you also need to have some additional logic in there that how do I prevent someone from pressing both the up and down button at the same time? We don't want both motors on at the same time. We want only one motor on at a time, but obviously if someone wanted to, they could press both of those push buttons at once. So that's one thing we want to do. Another thing would be, what if we were trying to close the door and there was, there was some object in the way. Let's say that our Jeep was actually hanging halfway out. The engine was having halfway out. So we try closing the door and it's going to get stuck on the hood. How do we want to prevent it so if we're going down that the system would automatically shut off if it took more than, say, 30 seconds to go down? Like right now we have this closed limit, but how would we also turn it off if it didn't didn't get to that limit in a fairly reasonable amount of time? And if it didn't get in 30 seconds, we'd want something else that would interrupt this circuit. So I don't know, those are just ideas that are floating about. this is just a simple go up. When it's all the way up, you can go down. But in real life, and when we said this is kind of a real life circuit, there are additional scenarios that you need to keep in mind. So this is kind of, garage door opening part 1, and you could probably have a part 2, part 3, until you fully had, a workable system that would take care of all things that aren't normal, like there being something in the way or somebody trying to press both up and down at the same time. I would think if somebody was trying to press both of them at the same time, what you'd want to do is you just want to have it stop in place. Those are just some things to think about when you're dealing with real life problems. So that's what our door open looks like. And now we're going to, and that just shows you how you use seal-in circuits. So I have something, something that causes it to turn on. So I've got something that causes it to turn on, but then I have another sensor, a different sensor that causes it to turn off. So, we've got this, everything here is stuff that tells it turn on, and then we have this little seal-in circuit, but part of that is the interrupter in there that tells it to turn off. And you will write a lot of programs in this fashion where you're going to have a signal that you turn on, and then another sensor or another push button or another memory bit or something that comes along later in time that tells it, hey, turn off. So that's the look at what you're going to be looking at upcoming. And we'll get into more of these circuits, and we'll start using some of the other devices that we talked about with counters, timers, some of these sequencers and stuff. And you can do a lot, and you can also do a lot just with using this stack light. You can kind of make up different scenarios, and you can have different functionality with some of these bits. You can also, and this is really powerful, is using this override view to put in something that really we have no control over this C3 or C4 except using this override, and we can actually force it into some condition that'll actually show that our program is working, and that's a valuable tool. So we'll see you next time. Thanks.